Okay, so we're optimizing perimeter and area. They've given us a couple requirements. Essentially that we have 100 meters of fencing, we have to build a rectangle, and we want the area to be a maximum. Now, if you guys know your geometry rules, essentially what that means is we need to build a square. We need to prove that we need to build a square. Okay? So we have some rectangle, and what we're going to do is create, like we should with all optimizing questions, a composite equation. So we have two equations. Our first one being the area. We'll call this x, scroll up a little, and y. Okay? So area is essentially your x times y. Okay? And your perimeter is 2x plus y. Okay? So we have two x's to add and two y's to add. This is our perimeter function. What we need to do in this question is set one of the variables equal to the other so that when we derive it, we're deriving for one specific variable. Now we have information about perimeter. So we're going to plug in our value for perimeter. Perimeter is equal to 100, so we have 100 is equal to 2x plus y. Okay? We can simplify this by dividing both sides by 2. We have 50 is equal to x plus y. And let's just set it equal to y. So 50 minus x equals y. With that information of our y, we're going to replace y in our area question. Area is equal to x multiplied by 50 minus x. Okay? We'll then have 50x subtract x squared as our area function, and that's area in terms of x. So now we can derive this to maximize. Area, the derivative of the area in terms of x will give us negative 2x plus 50. Okay. Our area at this point, whatever the constant is, we're going to set it equal to 0. We have negative 2x plus 50. Okay. We bring over 50. We have negative 50 is equal to negative 2x. X is equal to 25. Okay. Now this is where our rate of change would technically be 0. So whatever this would look like on a function, because we do have parameters too. We haven't talked about them yet. But this is hopefully a max at it. So we're assuming there's some type of maximum at the value of 25. There is a minimum. Anyone know what the minimum side length could be? 0. And what would the maximum side length be? 50. Okay? And let's think about those ideas. If x is 50, what does that mean? And the other x is 50. How wide or deep is our y? 0. So does it exist? No. So that parameter does not exist. Okay? And if x is 0, how long is y? Yes, same thing, but does it exist still? No. So neither of those exist. So technically, 0 and 50 do not exist. Okay? So that leaves us with only one value of 25 to maximize. So when we go to maximize this, our area is equal to 25 times y. We got to figure out what our y is in this case. So we go back to our perimeter. Perimeter being 100 is equal to 25 plus y. Okay, which essentially becomes 50 is equal to 25 plus y. What is y equal to? 25. And what type of shape does that make? Square. Okay. Oh, why did I leave it like that? Okay.